Hello and welcome. I'm so pleased you've chosen to spend this time with me tonight. Whether you're settling into bed after a long day, seeking a peaceful escape from your thoughts, or simply looking for a gentle journey into the unknown, you're in exactly the right place. Tonight, we're going to explore some of the most fascinating mysteries in our universe, not to find answers, because many of these mysteries have no answers yet, but to marvel at the questions themselves, to appreciate the profound unknowns that surround us, and to find peace in acknowledging that uncertainty is woven into the very fabric of existence. There's something deeply calming about contemplating mysteries. In our daily lives, we often feel pressure to know, to be certain, to have answers. But the universe reminds us that not knowing is natural, that mystery is fundamental, that some questions may never be fully answered, and that's perfectly okay. Tonight, as we explore these cosmic enigmas, let them wash away your need for certainty. Let them remind you that you're part of something much larger than yourself, something ancient and vast and profoundly mysterious. So, get comfortable now. Adjust your pillows just right. Let your body sink into your bed, feeling supported, feeling safe. Take a slow, deep breath. And let's begin our journey into the unknown, into dark matter and dark energy, into the nature of consciousness, into the possibility of other universes, into questions that have puzzled humanity's greatest minds and may continue to puzzle minds for generations to come. Let the mystery be soothing rather than troubling. Let the vastness be comforting rather than overwhelming. Let's explore the beautiful, peaceful unknown together. Dark matter surrounds us, yet we cannot see it. Let's begin with one of the most profound mysteries in modern physics: dark matter. This invisible substance makes up approximately 27% of the universe's total mass energy content, yet we cannot see it, cannot touch it, cannot directly detect it. It doesn't emit, absorb, or reflect light. It doesn't interact with electromagnetic radiation in any way we can currently measure. And yet, we know it's there because of its gravitational effects on visible matter, on galaxies, on the large-scale structure of the cosmos. The discovery of dark matter came gradually, through observations that didn't match expectations. In the 1930s, Swiss astronomer Fritz Zwicky was studying the Coma Cluster, a group of over 1,000 galaxies bound together by gravity. He measured how fast the galaxies were moving and calculated how much mass the cluster needed to prevent those galaxies from flying apart. The visible matter, all the stars and gas he could observe, wasn't nearly enough. There had to be much more matter there, matter he couldn't see. He called it dunkle Materie, dark matter. For decades, this observation was largely ignored or explained away. But in the 1970s, American astronomer Vera Rubin conducted careful studies of how galaxies rotate. She measured the speed of stars at different distances from galactic centers, expecting to find that stars farther out moved slower. Just like outer planets in our solar system orbit more slowly than inner planets. But that's not what she found. Stars at the edges of galaxies were moving just as fast as those closer to the center, sometimes even faster. This was impossible according to the laws of gravity and the visible matter alone. The only way to explain these flat rotation curves was to assume that galaxies are embedded in much larger halos of invisible matter. This dark matter extends far beyond the visible edge of galaxies, and its gravitational pull keeps outer stars moving faster than they otherwise could. Rubin's observations, confirmed across hundreds of galaxies, made dark matter impossible to ignore. So what is dark matter? Honestly, we don't know. It's one of the biggest mysteries in physics. We know what it isn't. It's not ordinary matter like stars, planets, or clouds of gas, which we call baryonic matter. It doesn't interact with light or electromagnetic forces in any detectable way. It only interacts through gravity, and possibly through unknown forces we haven't discovered yet. The leading hypothesis is that dark matter consists of particles that we haven't detected yet, particles that exist outside the standard model of particle physics. These might be WIMPs, weakly interacting massive particles that rarely interact with ordinary matter, but have mass and therefore gravity. Or they might be axions, hypothetical particles that are extremely light but incredibly numerous. Or they might be sterile neutrinos, particles similar to the neutrinos we know but even more elusive. Or they might be something else entirely, something we haven't even theorized about yet. Scientists around the world are conducting experiments to detect dark matter directly. Deep underground laboratories shield sensitive detectors from cosmic rays, waiting to catch the incredibly rare event of a dark matter particle colliding with ordinary atoms. Particle accelerators like the Large Hadron Collider attempt to create dark matter particles by smashing ordinary particles together at enormous energies. Space telescopes search for evidence of dark matter particles, annihilating each other in regions of high dark matter concentration. So far, despite decades of effort and billions of dollars spent, we have no direct detection. Dark matter remains stubbornly hidden, and yet its effects are everywhere. Dark matter provides the gravitational scaffolding on which galaxies form. In the early universe, dark matter clumped together first, creating gravitational wells into which ordinary matter fell, allowing gas clouds to collapse and form stars. Without dark matter, galaxies as we know them couldn't exist. The universe would be much emptier, with matter spread too thinly to form the structures we observe. Dark matter also affects the large-scale structure of the universe, the cosmic web of galaxies, galaxy clusters and enormous voids between them. Computer simulations of universe formation that include dark matter produce structures remarkably similar to what we observe. Simulations without dark matter produce universes that look nothing like our own. Dark matter isn't just an interesting addition, it's fundamental to cosmic architecture. There's something deeply mysterious and strangely peaceful about dark matter. It reminds us that most of what exists is hidden from us. We see only a small fraction of reality, the part that interacts with light, with electromagnetic radiation. The majority of the universe's matter is invisible, silent, undetectable, except through its gravitational influence. We're surrounded by mystery, literally immersed in a sea of invisible matter that we can barely begin to understand. This mystery also reminds us of how much we don't know. We often think of science as explaining the world, providing answers, reducing uncertainty. And science does do that. But science also continually reveals new mysteries, new questions, new depths of ignorance. Every answer opens new questions. Every discovery reveals how much more there is to discover. Dark matter is a perfect example. We've known about it for decades, but we're no closer to understanding what it actually is. The mystery deepens even as our knowledge grows. There's peace in accepting this. You don't need to know everything. You can't know everything. Even the universe's fundamental composition is mysterious to the world's most brilliant physicists. If they can acknowledge ignorance, if they can say, "We don't know," while continuing to explore and wonder, then you can too. You can release the burden of needing to understand everything, of needing certainty, of needing to have all the answers. Mystery is natural. Not knowing is the default state. And that's okay. Dark matter also teaches us about humility. We thought we understood gravity pretty well. We thought we knew what the universe was made of. And then observations revealed that most of the universe is something we can't even detect, something that doesn't fit into our theoretical frameworks. The universe is more complex, more strange, more mysterious than we imagined. This is humbling, but it's also exciting. There's so much more to discover, so much we don't yet understand. As you lie there, imagine yourself surrounded by dark matter. It's everywhere, passing through your room, through your body, through the earth. Dark matter particles are streaming through you right now, billions of them every second, completely undetected, leaving no trace, interacting with your atoms so rarely that you'll never feel it. You're immersed in mystery, literally bathed in the unknown, and yet you're safe, comfortable, at peace. The mystery doesn't harm you. The unknown doesn't threaten you. It simply exists, surrounding you, reminding you that reality extends far beyond what you can see or understand. Let that thought be comforting rather than unsettling. You don't need to understand dark matter to rest. You don't need to solve the mystery to sleep. You can simply accept that the mystery exists, that you're part of a universe filled with unknowns, and that's a beautiful thing. The dark matter will still be there tomorrow, still mysterious, still hidden. And you can rest now, held gently by forces you can see and forces you can't. Visible and invisible matter, all working together to create the universe you inhabit. Dark energy is accelerating the universe's expansion. If dark matter is mysterious, dark energy is even more so. While dark matter at least fits into our understanding of how gravity works, it has mass, it attracts other matter. Dark energy seems to do the opposite. It appears to be a force that pushes things apart, that works against gravity, that accelerates the expansion of the universe. And it's not a minor component. Dark energy makes up approximately 68% of the universe's total mass energy content. More than 2/3 of everything that exists is this mysterious energy we don't understand. The discovery of dark energy was completely unexpected, one of the most surprising findings in the history of astronomy. In 1998, two independent teams of astronomers were studying distant supernovae, exploding stars, using them as standard candles to measure cosmic distances and determine how fast the universe's expansion was slowing down. Everyone expected the expansion to be slowing, pulled back by gravity's attractive force. The question was how much it was slowing, which would determine the universe's ultimate fate. But that's not what the observations showed. Instead of slowing down, the universe's expansion was speeding up. Galaxies weren't just moving apart, they were moving apart faster and faster over time. This was so unexpected that both teams initially thought they'd made an error. They rechecked their data, looked for systematic mistakes, tried to find any explanation other than accelerating expansion. But the evidence was clear and reproducible. The universe's expansion really was accelerating. This discovery required a complete rethinking of cosmic dynamics. Something had to be pushing galaxies apart, working against gravity, causing acceleration. This something was dubbed dark energy, though energy might not be the right word. We don't really know what it is. It's invisible, permeates all of space, doesn't dilute as the universe expands, unlike matter, which spreads out and becomes less dense, and has a repulsive effect that manifests on cosmic scales. The leading explanation for dark energy is Einstein's cosmological constant, a term Einstein introduced into his equations of general relativity. Einstein originally added this constant to keep the universe static because, at the time, everyone believed the universe was neither expanding nor contracting. When Edwin Hubble discovered that the universe actually is expanding, Einstein reportedly called the cosmological constant his greatest blunder and removed it from his equations. But it turns out Einstein's blunder might have been right after all, just for different reasons than he thought. The cosmological constant can be interpreted as the energy density of empty space itself, what physicists call vacuum energy. According to quantum mechanics, empty space isn't truly empty. It seethes with virtual particles that pop into and out of existence, and these quantum fluctuations have energy. This vacuum energy could be what we're observing as dark energy. There's just one enormous problem. When physicists try to calculate how much vacuum energy there should be based on quantum mechanics, they get a number that's about 10^120 times larger than what we observe. That's a 1 with 120 zeros after it. This is arguably the worst prediction in the history of physics, a mismatch so spectacular, it's almost comical. So while vacuum energy might be part of the answer, there's clearly something fundamental we're not understanding correctly about how quantum mechanics and gravity relate to each other. Alternative explanations for dark energy include quintessence, a hypothetical dynamic field that changes over time and varies from place to place, unlike the cosmological constant, which is the same everywhere forever. Or maybe Einstein's general relativity needs to be modified on cosmic scales. Perhaps gravity works differently than we think when applied to the entire universe. Or maybe dark energy isn't real at all, and the observations have some other explanation we haven't thought of yet. The implications of dark energy are profound and somewhat unsettling if you think about them too much, though we'll try to keep this peaceful. If dark energy remains constant and continues accelerating the expansion, the universe will keep expanding forever, faster and faster. Eventually, distant galaxies will be moving away from us faster than the speed of light, not because they're moving through space faster than light, which is impossible, but because space itself is expanding so rapidly between us and them. In about 100 billion years, galaxies outside our local group will have moved so far away that light from them will never reach us again, no matter how long we wait. They'll disappear beyond the cosmic horizon. Observers in the far future living in our galaxy or the merged Milky galaxy might look out at the night sky and see nothing but darkness beyond their own galactic neighborhood. They'd have no evidence that other galaxies ever existed, no way to know about the broader universe, no ability to discover cosmology as we have. They'd think their galaxy was the entire universe, alone in infinite empty space. On even longer timescales, trillions of years from now, the accelerating expansion might become so extreme that it tears apart structures held together by gravity. First, galaxy clusters would be pulled apart, then individual galaxies. Eventually, even solar systems and planets might be ripped apart as space expands faster than gravity can hold them together. This hypothetical scenario is called the Big Rip, and while it's just one possibility among several, it's a reminder that dark energy's effects, while currently subtle, might become dramatic given enough time. But for now, dark energy is mostly just mysterious. It affects the universe's largest scales but doesn't influence daily life or even the structure of galaxies. Its effects only become apparent when looking at how the cosmos as a whole is evolving. On human scales, on solar system scales, even on galactic scales, dark energy is negligible. Gravity dominates. It's only when you step back and look at the universe as a whole that dark energy's influence becomes clear. There's something oddly comforting about dark energy's mystery. Here we are, barely able to comprehend our own planet, trying to understand the entire universe's fate. And we discover that most of the universe is made of something we don't understand at all. It puts our human concerns in perspective. Your worries, your problems, your daily stresses, they're real and valid, but they're also infinitesimally small compared to cosmic mysteries. Dark energy is accelerating the expansion of space itself, and yet you're here, safe in bed, alive, conscious, able to contemplate these mysteries. That's remarkable in itself. The mystery of dark energy also teaches us that the universe is under no obligation to make sense to us, to fit into our intuitions, to be comprehensible. We evolved to understand middle-sized objects moving at moderate speeds, prey animals, predators, tools, other humans. We didn't evolve to intuitively grasp quantum mechanics or cosmic expansion or the nature of vacuum energy. Our minds are not naturally equipped to understand the universe at its most fundamental levels. And yet, through mathematics, through careful observation, through scientific method, we can at least begin to map these mysteries. Even if we can't fully explain them, as you prepare for sleep, let the mystery of dark energy be a reminder that you're part of something far grander than you can comprehend. Forces you don't understand are operating on scales you can barely imagine, and they've been operating for billions of years before you were born, and will continue for billions of years after you're gone. You're a tiny part of an enormous cosmic story, and you don't need to understand the whole story to play your part. You don't need to solve the mysteries to live well, to find meaning, to rest peacefully. The dark energy will continue accelerating the universe's expansion, whether you understand it or not, whether you worry about it or not, whether you're awake or asleep. Right now in this moment, what matters is your rest, your peace, your well-being. The cosmos can wait. The mysteries will still be there tomorrow. For now, release your grip on the need to know, the need to understand, and simply rest in the vast, mysterious universe that somehow, against all odds, gave rise to you. We don't know why the universe exists at all. Perhaps the most fundamental mystery of all is the simplest question a child might ask. Why is there something rather than nothing? Why does the universe exist? This question has puzzled philosophers and physicists for millennia, and despite all our scientific progress, we still have no satisfactory answer. We can describe how the universe evolved from the Big Bang, We can trace the formation of atoms and stars and galaxies, but we cannot explain why there was a Big Bang in the first place, why physical laws exist, why anything exists at all. Imagine absolute nothingness, not empty space, because empty space is something. Not darkness, because darkness is the absence of light in a space where light could exist. True nothingness, no space, no time, no matter, no energy, no physical laws, no mathematical truths, literally nothing. This is almost impossible to imagine because our minds, existing within reality, struggle to conceive of the complete absence of reality. But try anyway, just for a moment, nothing. Why isn't that the case? Why isn't nothingness the default state? Why is there something instead? Some philosophers and theologians have argued that God created the universe, that a divine being chose to bring existence into being from nothingness. This shifts the question to why God exists, why there is a divine being rather than nothing, but it's at least an attempt at an answer. For those satisfied with religious explanations, the existence of the universe is part of a divine plan, and the mystery resolves into faith. But for those seeking naturalistic explanations, the question remains as puzzling as ever. Some physicists have proposed that the universe could arise spontaneously from nothing through quantum mechanics. In the quantum realm, things can pop into existence without cause, borrowing energy temporarily from the uncertainty principle. Perhaps the entire universe is such a quantum fluctuation, a temporary borrowing from nothing that happened to expand and persist. But this explanation requires quantum mechanics to exist in the first place, which means it's not explaining how something comes from true nothing, but rather how a universe could emerge from a quantum vacuum, which is something, not nothing. Others have suggested that the universe must exist because the alternative is logically impossible, that nothingness is incoherent or unstable, that existence is somehow necessary. But why would existence be necessary? What compels something to exist rather than nothing? These arguments often become circular or rest on assumptions that are themselves unexplained. The philosopher Martin Heidegger called this the fundamental question of metaphysics and suggested that the fact that we can ask it reveals something important about human existence. But he didn't really answer it either. The multiverse hypothesis, which we'll explore more later, suggests that our universe might be one of many, perhaps infinitely many, each with different physical laws and properties. In this view, we exist in a universe with properties that allow for life and consciousness simply because if we didn't, we wouldn't be here to wonder about it, a form of the anthropic principle. But this doesn't explain why a multiverse exists rather than nothing. So it pushes the question back without truly answering it. Some thinkers have proposed that the question itself might be flawed. That why implies purpose or cause in ways that don't apply to existence itself. Causes happen within time, but time itself is part of the universe. So asking what caused the universe might be like asking what's north of the North Pole, a question that seems meaningful but actually isn't, because it applies a concept beyond its domain of applicability. Maybe existence just is a brute fact that requires no explanation, that admits of no explanation. That simply is the case. This might sound unsatisfying, but there's a certain peace in it too. Not everything needs an explanation. Some things might just be fundamental, bedrock facts that don't reduce further. The existence of the universe might be one such fact. We can explore how the universe works, what laws govern it, how it evolved, but perhaps we cannot explain why it exists in the first place. And maybe that's okay. Maybe not every question has an answer, and maybe accepting that is part of wisdom. The mystery of existence also connects to the mystery of consciousness, which we'll discuss later. The fact that you're here, aware, thinking about existence, this is in some ways as mysterious as existence itself. Why is there subjective experience? Why is there an I reading these words, feeling feelings, having thoughts? This first-person perspective, this consciousness, is as mysterious in its own way as the universe itself. You exist, and you're aware that you exist, and both facts are deeply mysterious. There's something profoundly calming about contemplating the mystery of existence from the comfort of your bed. Here you are, indisputably real, conscious, alive. The universe exists. You exist within it. Neither fact has a clear explanation, and yet both are undeniably true. You're participating in the fundamental mystery simply by being here, by existing, by being conscious. You don't need to understand why you exist to exist. Existence precedes explanation. You are before you understand why you are. Throughout history, humans have created elaborate philosophies, religions, and scientific theories attempting to explain existence. Some find answers that satisfy them. Others remain uncertain. Still others embrace the mystery as irreducible. But regardless of which camp you're in, the practical reality remains the same. You exist. The universe exists. Life continues. Experiences happen. Meaning can be found or created within existence, even if existence itself remains mysterious. As you lie there, perhaps you can feel the mystery of existence in a peaceful way. Your heart is beating. You're breathing. You're conscious. None of this is explained in any ultimate sense. Why does life exist? Why does consciousness arise from matter? Why does anything exist at all? These mysteries surround you, undergird you, constitute you, and yet you're okay. You're here. You're real. The mystery doesn't prevent your existence or your experience or your peace. You can be deeply embedded in mystery and still find calm, still rest, still live a good life. You don't need all the answers. You don't even need most of the answers. You just need to be here, now, accepting what is rather than demanding to know why it is. Let the great mystery of existence be a comfort rather than a concern. You're part of something so profound that the greatest minds in history couldn't explain it. There's a certain peace in that, in being part of the ultimate mystery and existing despite not knowing why. Rest now, mysterious being in a mysterious universe, both real beyond doubt, both unexplained in any ultimate sense, both simply here now, being together. Time might not flow the way we think it does. Our experience of time is so fundamental to consciousness that we rarely question it. The past is gone, fixed, unchangeable. The present is now fleeting, constantly becoming past. The future is yet to come, open, full of possibility. Time flows from past through present into future like a river flowing downstream. This seems obvious, undeniable, as certain as anything can be. And yet physics suggests that this intuitive understanding of time might be completely wrong. That time might not flow at all, that past, present, and future might all exist simultaneously in a four-dimensional space-time, where now is subjective and perhaps even illusory. Einstein's theories of relativity revealed that time's not absolute, but relative. Different observers can disagree about which events are simultaneous, can experience different durations for the same processes, can even disagree about the order in which events occur. Time is interwoven with space into space-time, a four-dimensional fabric where the three dimensions of space and one dimension of time are unified. In this space-time view, the past and future exist just as really as the present. They're just located at different points in the time dimension, like how north and south exist just as really as here, despite being at different locations in space. This is the block universe view, where all of space-time, all of time from the Big Bang to the heat death of the universe, exists as a single, eternal, unchanging four-dimensional object. From this perspective, there is no special now that moves through time. Instead, every moment of time simply exists at its own location in space-time. Your birth exists. This moment exists. Your death exists. They don't take turns existing. They all exist simultaneously, just at different temporal locations. This seems to contradict our experience profoundly. We feel time flowing. We remember the past but not the future. We can affect the future but not the past. The present feels special, real in a way that past and future are not. How can physics tell us this is an illusion? But relativity is very clear. Simultaneity is relative. There is no universal now, and the structure of space-time is better described as a block than as a flowing river. Some physicists and philosophers argue that the flow of time is indeed an illusion, that what we call now is just our subjective experience of our particular location in space-time, no more objectively special than here is in space. The feeling of time passing, of experiencing a succession of moments, might emerge from how our consciousness processes memory and anticipation, not from any objective feature of time itself. We remember past states of the universe, but not future states, creating an arrow of time in our subjective experience, even if time itself doesn't flow. Others maintain that time really does flow, that there really is something special about the present moment, that the block universe view misses something important about reality. They point out that physics may describe the structure of space-time, but doesn't capture the phenomenology of temporal experience, the felt quality of existing in the now. Maybe consciousness is somehow fundamental to time's flow, or maybe there are aspects of reality that physics hasn't yet captured. The mystery deepens when we consider quantum mechanics. At the quantum level, before measurement or observation, particles exist in superpositions of multiple states, described by wave functions that evolve deterministically. But upon measurement, the wave function collapses into a single state. This collapse seems to introduce a fundamental distinction between past, collapsed, determined, and future, uncollapsed, probabilistic. Some interpretations of quantum mechanics suggest that the present moment is where possibility becomes actuality, where the future crystallizes into the past, giving now a special status. But other interpretations, like the many worlds interpretation, eliminate wave function collapse entirely, suggesting that all possible outcomes actually occur in branching universes. In this view, there's no collapse, no special present moment, just a continuously branching tree of possibilities, all existing in the block universe. The appearance of collapse, the feeling that one outcome actualized, is just your subjective experience of finding yourself in one particular branch rather than others. The thermodynamic arrow of time, the fact that entropy increases, that disorder grows, that you can scramble an egg but not unscramble it, gives time a direction even if it doesn't flow. The second law of thermodynamics says that in closed systems, entropy always increases or stays the same, never decreases. This creates an asymmetry between past and future. The past is the direction of lower entropy, the future is the direction of higher entropy. This might be why we remember the past but not the future, why causes precede effects, why time has an arrow even if it doesn't flow. But why does entropy increase? Why was the early universe in a state of such low entropy? The Big Bang was extraordinarily ordered, with matter and energy distributed very uniformly. From that low entropy beginning, entropy has been increasing ever since, and will continue increasing until the universe reaches maximum entropy in the heat death. But why did the universe start with low entropy? This is another deep mystery, tied to the mystery of the Big Bang itself. To why the universe began in the particular state it did rather than any other possible state. Some theories suggest that time might emerge from something more fundamental, that it's not a basic feature of reality, but rather something that arises from deeper, timeless laws. In quantum gravity theories, at the smallest scales and highest energies, time might dissolve into something else entirely, some more fundamental description where time as we know it doesn't exist. If this is true, then time is an emergent property, something that appears at our everyday scales but isn't part of reality's deepest level. There's something deeply mysterious and somewhat unsettling about questioning the nature of time. Our entire existence is structured by time. Our memories, our sense of self, our planning for the future, our regrets about the past. All of this assumes that time flows, that the past is gone and the future is yet to come. If time doesn't really flow, if past and future exist just as much as the present, it changes everything about how we understand ourselves and our lives. And yet, there's also something peaceful in the block universe view. If all of space-time exists eternally, then, in a sense, nothing is ever truly lost. Every moment you've experienced still exists at its location in space-time. Your childhood exists now, in the past region of the block universe. Your entire life, from birth to death, exists as a four-dimensional world line threading through space-time. You're not a fleeting moment of consciousness that will be extinguished. You're an extended structure in space-time that exists always, eternally, unchanging. This view also relieves some anxiety about the future. Whatever will happen already exists in the future region of space-time, if the block universe view is correct. You can't change it any more than you can change the past, because it already is what it is. This might sound fatalistic, but it can actually be liberating. You're relieved of the burden of infinite possibility, the anxiety of not knowing what will happen. It will happen what it already is in the block universe, and you'll experience it when you reach that point in space-time. Worrying won't change it. Of course, we don't know if the block universe view is correct. We don't know if time really flows or if that's an illusion. We don't know what time fundamentally is, or why it exists, or why it has an arrow, or whether the present is special. These are open questions, mysteries that physics hasn't solved. Different physicists and philosophers hold different views, and the evidence doesn't clearly favor one interpretation over others. Time remains deeply mysterious despite being our most familiar experience. As you lie there preparing for sleep, you're experiencing time in your immediate, subjective way, moments passing, drowsiness increasing, consciousness fading toward sleep. This experience is real regardless of what time ultimately is. Whether time flows or you're just moving through a static space-time, whether the future exists or is yet to be determined, your experience right now is the same. You're here now feeling what you feel, thinking what you think, gradually relaxing into sleep. Let the mystery of time be a reminder that your immediate experience is valid, even if you don't understand its ultimate nature. You don't need to know what time is to experience it. You don't need to resolve the philosophical puzzles to move through it. You can simply be in time or be a pattern in space-time, however you want to think about it, and that's enough. The mystery doesn't prevent your existence or invalidate your experience. It just adds depth, adds wonder, adds another layer of strangeness to the already strange fact of being conscious in a universe. So rest now, existing in time or as time or through time, however it ultimately works. Let your mind release its grip on the need to understand, the need to figure out whether time flows or you move through it, or it's all a static block. These questions have puzzled brilliant minds for decades and remain unresolved. You don't need to solve them tonight. You just need to rest, to let time pass, or let yourself move through it, to allow the mysterious progression of moments to carry you gently into sleep, where time becomes even more mysterious, where hours pass in what seems like minutes, where you experience but don't measure, where you exist but don't analyze. Time will continue in whatever way it continues, with or without your understanding. And you can rest in that, letting the river flow or the block be, letting time be mysterious while you are simply, peacefully here. Consciousness might be the universe's greatest mystery. Of all the mysteries we'll explore tonight, perhaps none is more intimate, more immediate, and more baffling than consciousness itself. Right now you're having an experience. You're aware. There's something it's like to be you, reading or hearing these words, feeling your body against your bed, thinking thoughts, experiencing the inner movie of subjective experience. This first-person perspective, this I that exists behind your eyes, this consciousness, what is it? How does it arise? Why does it exist at all? The hard problem of consciousness, as philosopher David Chalmers calls it, is explaining why and how physical processes in the brain give rise to subjective experience. We can explain in great detail how neurons fire, how brain regions process information, how sensory inputs are transformed into motor outputs. We can map brain activity correlated with different mental states. We're getting better at understanding the neural mechanisms underlying perception, memory, decision-making, and emotion. But all of this explains behavior and information processing, the easy problems of consciousness. None of it explains why there's subjective experience accompanying these processes, why there's something it feels like to be conscious. Consider color. When you see red, light of a certain wavelength hits your retina, triggering photoreceptors that send signals through your optic nerve to visual processing areas in your brain, where neurons fire in specific patterns. We can measure and map all of this, but none of this neural activity is red. The experience of redness, the subjective quality of that particular color sensation, what philosophers call a quale, isn't explained by any of this physical description. The redness of red, the painfulness of pain, the sweetness of sweet. These subjective qualities seem to be something over and above the physical processes, yet they're somehow produced by those physical processes. How? Why? Some philosophers and scientists are materialists. They believe consciousness must be entirely physical, produced by brain activity, even if we don't yet understand how. In this view, consciousness is what complex information processing feels like from the inside. When a system reaches a certain level of complexity, when it integrates information in particular ways, consciousness emerges. We don't fully understand the mechanisms yet, but in principle, consciousness should be explainable in physical terms, reducible to neuroscience, and ultimately to physics. Others are dualists. They believe consciousness is fundamentally non-physical. That mind and matter are two distinct types of things. In this view, your consciousness isn't produced by your brain, but rather interacts with it somehow. The brain is like a receiver or a filter, allowing consciousness to interface with the physical world but not creating consciousness itself. This view faces serious challenges. How can non-physical consciousness affect physical neurons? Where does consciousness come from? How does it work? But it captures the intuition many people have that consciousness feels different in kind from physical objects. That subjective experience can't be reduced to neural firing. Still others propose that consciousness might be a fundamental feature of reality, like mass or charge. This view, called panpsychism, suggests that consciousness, or some primitive form of experience, exists at all levels of reality, even in individual particles. Complex consciousness like ours emerges when many simple conscious entities combine in particular ways. But the basic ingredient, proto-consciousness, is built into the fabric of reality itself. This sounds strange, but it might solve the hard problem by not requiring consciousness to magically emerge from non-conscious matter, since all matter would already have some minimal form of experience. The integrated information theory, proposed by neuroscientist Giulio Tononi, attempts to quantify consciousness and explain when and why it arises. This theory suggests that consciousness is identical to integrated information, roughly, information that's more than the sum of its parts, information that's unified into a coherent whole rather than existing as separate pieces. Systems with high integrated information are highly conscious. Systems with low integrated information have little or no consciousness. This theory makes specific predictions and can be mathematically formalized, though whether it truly solves the hard problem remains debated. The global workspace theory, proposed by Bernard Bars and developed by others, suggests that consciousness arises when information becomes globally available to multiple cognitive systems. In this view, your brain contains many specialized processors working on specific tasks: vision, language, memory, planning, emotion. Most of this processing happens unconsciously. Consciousness occurs when information from these specialized systems is broadcast to a global workspace where it becomes available to all systems, enabling flexible response, planning, and verbal report. This explains why we're conscious of some mental processes, but not others. But it doesn't explain why global broadcasting feels like something, why there's subjective experience of the broadcasted information. The mystery deepens when we consider that we can't even be certain that other beings are conscious. You know you're conscious because you directly experience it. But how do you know I'm conscious? How do you know anyone else is conscious? You observe behavior that suggests consciousness. People report experiences, respond to stimuli, act as if they're aware. But behavior is just physical activity, which could theoretically occur without any accompanying experience. A sophisticated robot might behave identically to a conscious person without actually experiencing anything. This is the problem of other minds. We generally assume other humans are conscious because they're similar to us. Same brain structure, same species, same behaviors. Most of us extend consciousness to mammals and probably birds because they have similar nervous systems and behave in ways suggesting experience. Do fish feel pain? Do insects? Do plants? Do bacteria? Where does consciousness begin and end? We don't know. We have our intuitions and assumptions, but we lack objective criteria for determining what systems are conscious and what aren't. This creates philosophical zombies, the thought experiment of beings that are physically identical to conscious humans, behave exactly like conscious humans, but have no subjective experience, no inner life, no consciousness. Are philosophical zombies possible? Materialists usually say no. If something is physically identical to a conscious being, it must be conscious, because consciousness is just what certain physical configurations do. Dualists might say yes, consciousness is separate from physical configuration, so you could have the configuration without the consciousness. The question reveals deep disagreements about the nature of consciousness. Consciousness also has strange properties that don't map easily onto physical descriptions. Your experience right now is unified. You experience a single, coherent flow of consciousness, not separate, disconnected streams. Yet your brain has billions of neurons firing semi-independently, processing information in parallel. How does this distributed neural activity create unified experience? This is the binding problem. It is how separate pieces of information bind together into unified conscious experience. Your consciousness also has what philosophers call intentionality. It's always about something. You're never just conscious. You're conscious of things. Your thoughts have content, represent things, mean something. How does physical brain activity acquire this aboutness, this meaning, this intentionality? Neurons firing are just electrical and chemical processes. How do they become thoughts about your grandmother, memories of yesterday, plans for tomorrow, feelings about your life? The relationship between physical processes and mental content remains deeply mysterious. The neural correlates of consciousness, specific brain. Activities that correlate with conscious experiences have been identified for various states. The claustrum, a thin sheet of neurons, might integrate information across the brain. The thalamus and cortex have reciprocal connections that might generate consciousness. Specific patterns of neural synchrony correlate with conscious awareness. But correlation isn't explanation. Just because brain activity X always accompanies conscious experience Y doesn't tell us why X produces Y or what the relationship between them is. Some mysteries surrounding consciousness are even more perplexing. Why do we have subjective experience at all? From an evolutionary standpoint, you'd think behavior is what matters. Organisms that behave adaptively survive and reproduce. Why add subjective experience on top? What work does consciousness do that couldn't be done by sophisticated unconscious information processing? Or is consciousness an inevitable byproduct of certain types of information processing, not selected for but unavoidable, given the way brains work? The mystery of consciousness also touches on identity and the self. What makes you you? Your body changes constantly. You're made of different atoms than 7 years ago. Your brain changes, neurons die, connections form and dissolve, memories change. Yet you feel like the same person. What is this self that persists through change? Is it an illusion, a narrative your brain constructs? Or is there something real and persistent that constitutes your identity? And if you could upload your consciousness to a computer, would it be you or a copy? Would there be something it's like to be that upload, or would it be a philosophical zombie? These questions have no clear answers. States of consciousness also pose mysteries. What happens during deep sleep? You're unconscious, yet your brain is active, sometimes more active than during waking. Where is consciousness then? Anesthesia can turn consciousness off and on like a light switch. What's happening? Near-death experiences report consciousness persisting when brain activity is minimal or absent, though this is controversial and disputed. Altered states from meditation, psychedelics, or intense experiences suggest consciousness is more fluid and variable than ordinary waking state suggests, the mystery of consciousness is unique because it's both the most immediate thing you're experiencing it right now and the most difficult to study scientifically. Science typically operates by objective observation, but consciousness is inherently subjective, knowable directly only to the one experiencing it. This creates a fundamental challenge. How do you objectively study something that's essentially subjective? How do you get outside consciousness to examine it when consciousness is always your starting point, the perspective from which you examine everything else? Despite decades of neuroscience, philosophy, psychology, and cognitive science, we're not much closer to solving the hard problem than we were when it was first articulated. We know vastly more about how brains work, but we're no closer to explaining why brain activity feels like something. This might be the hardest problem humans have ever faced, perhaps even insoluble with our current conceptual tools and understanding. And yet, there's something peaceful about being a mystery to yourself. Your consciousness, this awareness, this experience of being you, is both the most certain thing, Descartes' I think, therefore I am, and the most mysterious. You are an unsolved puzzle, a question without an answer, a phenomenon that the universe has produced but cannot explain. You're the universe becoming conscious of itself, as Carl Sagan said, and neither you nor science fully understands how that's possible. This mystery doesn't prevent you from existing, from experiencing, from living a full life. You don't need to understand consciousness to be conscious. You don't need to solve the hard problem to have experiences, to feel feelings, to think thoughts. The mystery is fundamental but doesn't interfere with the reality. You're conscious, undeniably so, and that's enough. The explanation can wait, might never come, and that's okay. As you drift toward sleep, your consciousness will change. It will become less focused, more diffuse. Images and thoughts will arise unbidden. Boundaries between self and world might blur. Eventually, you'll lose consciousness entirely for periods, entering dreamless sleep where there's no experience, no awareness, no you. Then you might dream, consciousness returning in strange forms, creating impossible worlds, narratives that make sense in the moment, but dissolve upon waking. Then you'll wake, consciousness returning to its familiar form, and you'll take it for granted once again. This nightly cycle of consciousness changing, disappearing, transforming, returning is itself mysterious. Where does consciousness go during deep sleep? Does it truly disappear or just change form? When you dream, is that really you experiencing the dream or some partial version of you? When you wake, is it the same consciousness that went to sleep? These aren't just philosophical questions, but point to real mysteries about consciousness's nature. So rest now, mysterious conscious being, aware in ways you cannot explain, experiencing in ways science cannot fully describe, existing as a question mark to yourself and to the universe. Your consciousness will shift and change as sleep approaches, demonstrating its fluid, mysterious nature. You don't need to understand it. You just need to be it, to experience it, to let it do what it does naturally, transform through the stages of sleep, rest, restore, and eventually return you to waking consciousness tomorrow. The mystery of what you are, of what consciousness is, will remain. And that's perfectly, peacefully fine. We might live in one of many universes. Let's explore another mind-bending possibility that our universe might not be the only universe. The multiverse hypothesis, in various forms, suggests that reality is vastly larger than the observable universe we inhabit, that there might be countless other universes existing alongside ours, each perhaps with different physical laws, different histories, different possibilities realized. This idea, once purely philosophical speculation, has emerged from serious physics and cosmology, though it remains controversial and largely untestable. One version of the multiverse comes from cosmic inflation, the theory that explains why our universe is so uniform on large scales. Inflation proposes that in the first fraction of a second after the Big Bang, space expanded exponentially fast, growing from subatomic size to perhaps larger than the observable universe today in less than a trillionth of a second. This inflation smoothed out irregularities, explaining why the universe looks remarkably similar in all directions and why space is so flat. But if inflation happened once, it probably happened many times. Inflation might be eternal, constantly creating new, expanding regions of space, new bubble universes, within an ever-inflating background space. Our observable universe would be just one bubble among countless others, each beginning from its own local Big Bang, each perhaps with different physical parameters. Some bubbles might have different force strengths, different numbers of dimensions, different particles and fields. Most would be lifeless, but some, by chance, would have conditions allowing for complexity and life. Another version comes from quantum mechanics, specifically the many worlds interpretation proposed by physicist Hugh Everett. In the standard Copenhagen interpretation, quantum systems exist in superpositions of multiple states until measured, at which point the wave function collapses to one state. But collapse is mysterious. What counts as measurement? How does it work? When exactly does it happen? The many worlds interpretation eliminates collapse entirely. Instead, it proposes that all possible outcomes of quantum measurements actually occur, but in separate branching universes. When you measure a quantum system, the universe splits into multiple versions, one for each possible outcome. In one branch, you measure spin-up. In another, spin-down. Both happen, but in different universes that can never interact again. You experience only one branch, the one you're in, but other versions of you exist in other branches, experiencing the other outcomes. If many worlds is correct, the number of universes is staggering and constantly increasing. Every quantum event with multiple possible outcomes creates new branches. Given the countless quantum events happening every instant throughout the universe, the number of worlds must be incomprehensibly large, possibly infinite. Every possible history that could have happened did happen in some branch. Every decision you could have made, you did make in some universe. All possibilities are realized somewhere in the multiverse. A third version involves the mathematical universe hypothesis proposed by physicist Max Tegmark. This suggests that every mathematically consistent structure exists physically somewhere. If mathematics describes possible universes, and if all mathematical structures are equally real, then all possible universes exist. This would include universes with different physical laws, different numbers of dimensions, different types of forces and particles, even universes with entirely different fundamental structures that we can't imagine because they'd be nothing like our universe. The anthropic principle offers one reason to take multiverses seriously. Our universe has many properties that seem fine-tuned for life. The cosmological constant is small enough that structure can form, but not zero. The strength of gravity is balanced perfectly with other forces. The ratio of matter to antimatter is just right. Change almost any fundamental constant by a small amount, and universes become sterile. No atoms, no stars, no planets, no life. Why is our universe so precisely tuned? One answer is design. An intelligent creator fine-tuned the universe for life. Another is luck. We got incredibly fortunate. But the multiverse offers a third explanation. If countless universes exist with all possible combinations of properties, some will inevitably be life-permitting purely by chance. We observe one of those universes not because we're special, but because we must. We couldn't exist in universes with properties that don't permit life. This is selection bias on a cosmic scale. The multiverse hypothesis is controversial because it seems untestable. If other universes are truly separate from ours, if we can never detect or interact with them, can we call them scientific? Science traditionally requires testability, observable predictions that can be confirmed or refuted. Multiverse theories make few, if any, testable predictions about our universe. Some physicists argue they're not even wrong. They're not wrong because they're so flexible they can accommodate any observation. They're metaphysics, not physics. But defenders argue that multiverse theories arise naturally from well-tested physical theories: inflation, quantum mechanics, string theory. We don't postulate multiverses to explain fine-tuning. We discover them as consequences of theories developed for other reasons. If a theory successfully explains many phenomena and also predicts a multiverse, should we accept the theory but reject its multiverse prediction just because it's untestable? That seems inconsistent. Some possible indirect tests exist. If our universe is one of many and typical among life-permitting universes, we might expect to see typical values for various parameters among such universes. We can compare observed values with distributions predicted by different multiverse models. If inflation is eternal, it might leave detectable signatures in the cosmic microwave background, patterns that reveal our universe's bubble structure, or even collisions with other bubbles. These observations don't prove the multiverse, but they provide some testability. The philosophical implications of multiverses are profound. If all possible universes exist, then everything that can happen does happen somewhere. Every possible history plays out. Every possible version of you exists in some universe. This might seem to diminish meaning. If everything happens, does anything matter? But you could argue the opposite. Your choices still matter for which branch you experience, for what happens in this universe, even if alternatives occur elsewhere. You still make real decisions with real consequences for yourself and others in your branch. There's also the question of probability in a multiverse. If infinitely many universes exist, does probability mean anything? You might think any possible observation, however unlikely, should be assigned equal probability if infinite universes realize all possibilities. This creates paradoxes and puzzles that physicists and philosophers are still grappling with. How do you do science or make predictions in an infinite multiverse? These conceptual challenges haven't been fully resolved. Some versions of the multiverse are stranger than others. The patchwork multiverse suggests that space is infinite, and if space is infinite, all possible configurations of matter must repeat infinitely often. There would be infinitely many regions identical to our observable universe, containing people identical to you, having identical experiences. In fact, there'd be infinite copies of you, scattered across infinite space. This follows from pure logic if space is truly infinite, i.e., finite number of possible configurations in infinite space means configurations must repeat. Other speculative ideas include simulated universes, the hypothesis that our reality might be a simulation running in some higher reality's computers. If it's possible to simulate conscious beings, and if technological civilizations eventually create many such simulations, then statistically you're more likely to be in a simulation than in the base reality, simply because simulations vastly outnumber base realities. This argument, while speculative, has been taken seriously by some physicists and philosophers. If we're in a simulation, the multiverse would include all simulations, plus whatever base reality runs them. There is something both unsettling and oddly comforting about multiverses. Unsettling because it challenges the uniqueness and centrality of our universe, our reality, our existence. We're not just one planet among billions, one galaxy among trillions. We might be one universe among infinitely many, utterly typical, completely unremarkable on the largest scale. But comforting because it means reality is vastly larger, richer, more diverse than we can observe. Every possibility is realized somewhere. Nothing is lost because somewhere every choice was made differently. Every life lived differently. Every outcome occurred. The multiverse also provides perspective on our problems and concerns. Your struggles, your worries, your achievements, they're real and important in this universe, in your branch of reality. But in the largest possible context, in the multiverse as a whole, they're infinitesimally small pieces of an incomprehensibly vast totality. This isn't nihilistic. Your life still matters to you and those around you. But it does suggest that your problems, however large they feel, are small in the cosmic scheme, that the universe will continue whether you solve them or not, that you can release the weight of thinking everything depends on you. As you prepare for sleep, imagine the multiverse in whatever form speaks to you, perhaps infinite bubble universes inflating from an eternal background, perhaps quantum branches splitting at every moment. Perhaps a mathematical ensemble of all possible universes? Perhaps simulations nested within simulations. Somewhere in some universe, another version of you is also going to sleep, or perhaps already asleep, or perhaps wide awake, dealing with different circumstances. Or perhaps no such version exists because the multiverse is a fantasy. Either way, you're here now, in this universe, this branch, this reality. What matters is your experience in this universe, your life in this branch, your reality here and now. The multiverse, if it exists, is unreachable and irrelevant to your immediate concerns. You can only affect and experience this universe, this timeline, this version of events. So focus here on your rest, on your peace, on this moment of surrender to sleep. The multiverse, vast beyond imagining or utterly fictional, can wait. For now, there's just this universe, this moment, this breath, this gradual dimming of consciousness into sleep. Let infinite possibilities exist elsewhere. Here now there's just you, resting, peaceful, letting the strange and mysterious cosmos, single or multiple, hold you gently as you sleep. The universe's fine-tuning suggests something we don't understand. One of the most perplexing features of our universe is how precisely its fundamental constants are balanced to allow for complexity and life. Change almost any constant by a tiny amount. Adjust gravity's strength, shift the electromagnetic force, tweak the cosmological constant, and you get a sterile universe where stars don't form, atoms don't exist, or everything collapses immediately. The precision required for a life-permitting universe is so extreme that it's become one of physics's deepest mysteries. Consider the cosmological constant, the term representing dark energy strength. Its value is about 10 or 120 in fundamental units. If it were much larger, the universe would expand so rapidly that matter couldn't clump together to form galaxies. If it were negative, the universe would collapse before stars could form. Why is it precisely the tiny value it is? When physicists try to calculate what the cosmological constant should be based on quantum field theory, they get values 100 to 20 orders of magnitude larger. This is the worst prediction in physics, and it's a complete mystery why the actual value is so small. The ratio of the electromagnetic force to the gravitational force is about 10 to 36. Gravity is vastly weaker than electromagnetism. This seems arbitrary, but if gravity were much stronger relative to electromagnetism, stars would burn out too quickly for life to evolve. If gravity were weaker, stars wouldn't ignite at all. The current ratio allows for stable, long-lived stars, essential for planets and life. The strong nuclear force which binds protons and neutrons together in atomic nuclei is precisely tuned. Increase it slightly, and all hydrogen converts to helium in the Big Bang, leaving no hydrogen for water or organic chemistry. Decrease it slightly and complex elements can't form. The current strength allows for hydrogen, a variety of stable elements, and nuclear fusion that powers stars. The difference in mass between protons and neutrons is also critical. Neutrons are slightly heavier, just enough that they decay into protons in about 15 minutes when free. This mass difference is 0.4%. If it were slightly different, chemistry would be impossible, or all matter would be either protons or neutrons, preventing complex structures. Even the number of spatial dimensions seems fine-tuned. In 2 dimensions, complexity would be extremely limited. Nerve signals couldn't cross without interfering, for instance. In 4 or more spatial dimensions, orbits would be unstable, and atoms couldn't exist in their current form. 3 spatial dimensions provide the right balance for complexity, stable systems, and the kind of chemistry necessary for life. The initial conditions of the universe also seem extraordinarily fine-tuned. The balance between the universe's expansion rate and its density is precise. If expansion were slightly faster, matter would be too dispersed to form structures. If expansion were slightly slower, the universe would have collapsed long ago. The current balance allows for galaxies, stars, and planets. The early universe's smoothness and uniformity are also puzzling. The cosmic microwave background shows that temperature varied by only about 1 part in 100,000 hours across the sky in the early universe. This uniformity allowed for structure formation without creating a lumpy, inhospitable universe. But why was the universe so smooth? Inflation theory provides a mechanism, but why did inflation happen? Why did it produce precisely the right conditions? Scientists have proposed various explanations for this fine-tuning. The theistic explanation suggests an intelligent designer deliberately set the constants to allow for life. God fine-tuned the universe. This provides an explanation but raises further questions. Why would a designer want to create life? What is the designer's nature and origin? For some, this explanation is satisfying. For others, it simply pushes the mystery back. The multiverse explanation, which we discussed earlier, suggests that countless universes exist with all possible values for fundamental constants. We observe a fine-tuned universe because we must. We couldn't exist in universes with different values. This explains fine-tuning through selection bias, but requires accepting that vast numbers of unobservable universes exist, which many find unsatisfying. The "it's just luck" explanation acknowledges that someone has to win the cosmic lottery, and we did. This seems unsatisfying because the odds are so astronomically small, but it's logically possible. Perhaps we simply got lucky, and there's no deeper explanation. This requires accepting that our existence is extraordinarily improbable, but happened anyway. Some physicists hope for a future theory of everything that will show why constants have the values they do, that they couldn't be otherwise. Perhaps some undiscovered physics constrains all constants to their current values, making the apparent fine-tuning an illusion. We think constants could vary, but maybe they can't. Maybe there's only one possible universe, and it happens to permit life. This would be elegant but seems unlikely given current understanding. Others argue that fine-tuning might be an illusion created by our limited imagination. Perhaps life could exist with very different physical laws. Maybe we're too focused on life as we know it, carbon-based, requiring water, needing stars. Perhaps other universes with different constants could support entirely different forms of complexity and consciousness. We assume only our kind of universe works because we can't imagine alternatives, but our failure of imagination doesn't prove anything. The fine-tuning mystery connects to other mysteries. Why do physical laws exist at all? Why these laws specifically? Why is the universe mathematical, describable by elegant equations? Why does nature obey principles of symmetry and conservation? These meta-questions about why physics has the structure it does are as puzzling as specific fine-tuning. Questions Eugene Wigner famously wrote about the unreasonable effectiveness of mathematics in the natural sciences. Mathematics, invented by humans to solve practical problems, turns out to describe the universe with uncanny precision. Physical laws can be expressed in beautiful mathematical equations. Abstract mathematical structures discovered for their own sake turn out to describe physical reality. Why is mathematics discovered or invented? Does it exist independently of humans? Does the universe know mathematics? These questions have no clear answers but point to deep connections between mind, mathematics, and physical reality. The fine-tuning mystery also relates to consciousness. If the universe weren't fine-tuned for life, consciousness wouldn't exist to observe the universe. In a sense, the universe's fine-tuning for consciousness is necessary for the universe to be observed. Some physicists take this seriously, suggesting consciousness plays a fundamental role in reality, that the universe needs observers. This approaches Eastern philosophical ideas about consciousness and reality being interdependent. But it's not clear if it solves anything or just restates the mystery. There's something peaceful about accepting that the universe is fine-tuned for whatever reason, and that we're here as a result. Whether it's design, luck, multiverse selection, or unknown physics, the result is the same. You exist in a universe that allows for your existence. You're not an accident in the sense of being impossible or absurd. You're possible. Therefore, you exist. The universe's properties permit you, enable you, make you actual, rather than merely conceivable. This can feel like a gift, though from whom or what is unclear. You exist against incomprehensibly long odds, the result of precise cosmic fine-tuning and billions of years of evolution. Every constant, every law, every historical contingency had to be just right for you to be here, conscious, reading these words. That's remarkable, whatever the explanation. You're cosmically improbable, yet undeniably real. As you rest, consider that your existence required the universe to be precisely what it is. Change almost anything about the cosmos, and you wouldn't be here. In that sense, the entire universe's history, its laws, its constants, all conspired to make you possible. You're woven into the fabric of reality in deep ways. The mystery of fine-tuning is your mystery too. Why are you possible? Why does the universe permit your type of existence? These questions have no clear answers, but they add wonder to the fact of your being. So sleep now, finely tuned creature in a finely tuned cosmos, both mysteriously balanced, both improbably here, both real despite the odds. The precise constants that make you possible will continue holding stable while you sleep, maintaining the universe's structure, keeping atoms together, keeping stars burning, keeping the cosmos hospitable for consciousness. You can rest in that stability, that reliability, even while acknowledging the mystery of why it's stable in precisely this way. The fine-tuning that permits your existence permits your rest too. Trust it. Trust the universe that somehow, mysteriously, makes you possible, and let that trust carry you into peaceful sleep. Conclusion. Mystery is woven into existence itself. As we near the end of our journey through cosmic mysteries, let's reflect on what these unknowns tell us about reality and about ourselves. We've explored dark matter and dark energy, the nature of time and consciousness, the possibility of multiverses, the fine-tuning of physical constants. These aren't minor gaps in knowledge that will be filled soon. These are deep mysteries that may remain mysterious for centuries, perhaps forever. And there's something profoundly peaceful in that recognition. Our universe is more mysterious than it is understood. We know a lot: how stars form, how galaxies evolve, how atoms work, how chemistry enables life. Science has been remarkably successful at explaining the natural world. But the more we learn, the more mysteries we uncover. Every answer reveals new questions. Every discovery shows how much we don't know. The boundary of knowledge expands, but so does the boundary between known and unknown. The mystery grows alongside understanding. This should be humbling. The greatest scientific minds humanity has produced, Einstein, Bohr, Hawking, countless others, devoted their lives to understanding the universe. They made enormous progress, discovered deep truths, expanded human knowledge more in a few decades than previous millennia had achieved. And yet, when they reached the end of their careers, when they surveyed what they'd accomplished, they all acknowledged how much remained mysterious, how many questions they couldn't answer, how vast the unknown still was. If they couldn't solve these mysteries with their genius and dedication, you certainly don't need to solve them tonight. You can release the burden of needing to understand everything, of feeling that uncertainty is a problem to be solved. Uncertainty is fundamental. Mystery is woven into reality's fabric. Not knowing isn't a temporary condition that will be fixed eventually. It's a permanent feature of existence for finite beings in an infinite universe. This recognition can be liberating. You don't have to have all the answers. You don't have to understand dark energy or consciousness or why the universe exists. Nobody does. The mysteries we've explored tonight puzzle the world's smartest people. Your confusion, your uncertainty, your inability to comprehend these things, that's normal, appropriate, shared by everyone, including experts. You're not failing by not understanding. You're participating in the human condition, the condition of limited beings confronting unlimited mystery. There's also beauty in mystery. A universe completely understood would be, in some sense, finished, exhausted, no longer capable of surprising us. But a mysterious universe promises endless discovery, endless wonder, endless opportunities to be amazed. Every mystery is an invitation to curiosity, to exploration, to maintaining a sense of wonder about existence. Children naturally have this wonder. Everything is new and mysterious. Adults often lose it, assuming we understand things we actually don't. Contemplating cosmic mysteries can restore that childlike wonder, that recognition that we're surrounded by things we don't understand, and that's marvelous. The mysteries also connect us to something larger than ourselves. When you contemplate dark matter, you're thinking about the same mystery thousands of physicists worldwide are grappling with. When you wonder about consciousness, you're joining a philosophical conversation that extends back millennia and forward indefinitely. These mysteries are not just your mysteries, they're humanity's mysteries, questions we face together. There's communion in shared puzzlement, solidarity in collective ignorance. Perhaps most importantly, mystery makes room for meaning that might not exist in a fully determined, completely understood universe. If everything were explained, if all questions were answered, if physics could tell us everything about everything, would life feel more meaningful or less? Many people find meaning precisely in the unexplained, in the gaps, in the possibility that reality exceeds our understanding. Mystery creates space for wonder, for spirituality, for philosophical speculation, for art and poetry and religion, for all the human responses to existence that go beyond pure scientific explanation. This recognition can be liberating. You don't have to have all the answers. You don't have to understand dark energy or consciousness or why the universe exists. Nobody does. The mysteries we've explored tonight puzzle the world's smartest people. Your confusion, your uncertainty, your inability to comprehend these things, that's normal, appropriate, shared by everyone, including experts. You're not failing by not understanding. You're participating in the human condition, the condition of limited beings confronting unlimited mystery. There's also beauty in mystery. A universe completely understood would be, in some sense, finished, exhausted, no longer capable of surprising us. But a mysterious universe promises endless discovery, endless wonder, endless opportunities to be amazed. Every mystery is an invitation to curiosity, to exploration, to maintaining a sense of wonder about existence. Children naturally have this wonder. Everything is new and mysterious. Adults often lose it, assuming we understand things we actually don't. Contemplating cosmic mysteries can restore that childlike wonder, that recognition that we're surrounded by things we don't understand, and that's marvelous. The mysteries also connect us to something larger than ourselves. When you contemplate dark matter, you're thinking about the same mystery thousands of physicists worldwide are grappling with. When you wonder about consciousness, you're joining a philosophical conversation that extends back millennia and forward indefinitely. These mysteries are not just your mysteries. They're humanity's mysteries, questions we face together. There's communion in shared puzzlement, solidarity in collective ignorance. Perhaps most importantly, mystery makes room for meaning that might not exist in a fully determined, completely understood universe. If everything were explained, if all questions were answered, if physics could tell us everything about everything, would life feel more meaningful or less? Many people find meaning precisely in the unexplained, in the gaps, in the possibility that reality exceeds our understanding. Mystery creates space for wonder, for spirituality, for philosophical speculation, for art and poetry and religion, for all the human responses to existence that go beyond pure scientific explanation. This doesn't mean abandoning science or reason. Science is humanity's most successful tool for understanding reality, and it should continue pursuing knowledge wherever it leads. But science itself reveals that complete knowledge may be impossible, that fundamental limits exist, that some questions may be unanswerable in principle. Gödel's theorems showed that mathematical systems can't prove their own consistency. Quantum mechanics showed that perfect prediction is impossible. The universe itself seems to resist complete understanding, to maintain pockets of irreducible mystery. Living with mystery means developing comfort with uncertainty, with not knowing, with ambiguity. This is a skill, a practice, a way of being. Modern culture often demands certainty, clear answers, definitive solutions. But reality doesn't always provide these. Sometimes the honest answer is I don't know. It's complicated. The mystery remains. Learning to be okay with these answers, to not need closure or certainty, to hold questions without demanding immediate answers, this is wisdom. The mystics of various traditions have long understood this. They speak of the mystery at the heart of existence, the unknowable divine, the limits of conceptual understanding. They practice not knowing as a spiritual discipline, recognizing that the most important truths might not be the ones we can articulate or prove, but rather the ones we experience directly, the ones that reveal themselves in stillness and receptivity. Science and mysticism arrive at similar conclusions from different directions. Reality is more mysterious than it appears, and humility before the unknown is appropriate. As you finally surrender completely to sleep, let all these mysteries be. Dark matter exists whether you understand it or not. Consciousness continues whether you explain it or not. Time flows or doesn't flow regardless of your opinion. The universe is fine-tuned or not, single or multiple, explained or inexplicable, and your sleep tonight won't resolve any of this. These mysteries are vast, ancient, and will persist long after you wake. What matters now is your rest, your peace, your well-being in this moment. You don't need to solve cosmic mysteries to sleep well. You don't need certainty to find peace. You can rest in the mystery held by forces and processes you don't understand, but that have sustained life for billions of years, that have brought you into existence against incomprehensible odds, that continue every moment to make your existence possible. Sleep now, mysterious being in a mysterious universe. You are a question mark conscious of itself, awareness arising from matter in ways no one fully understands, existing in a cosmos whose origins and nature remain profoundly puzzling. You're made of atoms produced in dying stars. You're breathing oxygen created by ancient algae. You're thinking thoughts through mechanisms neuroscience can't fully explain. Every moment of your existence is miraculous and mysterious, ordinary and inexplicable, both at once. The mysteries will remain when you wake. Dark matter will still be invisible, consciousness still unexplained, the universe still strange and wonderful, and you'll still be here, alive, aware, participating in the great mystery simply by being. That's enough. More than enough. It's everything. Rest well, peaceful dreamer, in the gentle embrace of all that is unknown.